everybody. I'm Dr. Meenakshi from GVM Girls College, Sonipat. In today's lecture, we shall study about permutations and combinations. Students, in our daily life, we shall come across the situations where we have to arrange or select certain things out of so many given things. The probable number of ways can be calculated with the help of permutations and combinations. So before going to the topic in detail, let's first discuss some important notations that will be useful throughout this topic. The first among all is factorial notation. Factorial, we write it as n factorial. And what does n factorial means? Here n is a natural number. This notation is for factorial. So n factorial means the continued product of first n natural numbers up to n. Right? 1, 2, 3 continued. You cannot skip any of the terms from 1 to n. So the continued product of first n natural numbers. You can also write this notation in the reverse way also. N, then n minus 1, n minus 2 and so on up to 1. Both notations are the same. In the first, we have increased the factor by 1. In the second, we have decreased the factor by 1. So you can choose any of these notations. From the second notation, we can have one deduction that n, if I separate this n from the remaining terms are the product of first n minus 1 natural numbers. Okay. So the product of first n minus 1 natural numbers is n minus 1 factorial. So it is very clear that n factorial is n into n minus 1 factorial. Okay. We can further extend this notation of n minus 1 factorial to n. This n minus 1 factorial is n minus 1 into n minus 2 factorial and so on. So this formula is to simplify the numerical problems. Right. One another definition is 0 factorial. 0 factorial. So 0 factorial is not, it doesn't make any sense to define the 0 factorial from this expression. So 0 factorial is independently defined as 1 and that can be, we shall prove it later with the help of permutations. Till then, we'll just keep in mind that 0 factorial is 1. Also, you should keep in mind that the factorial notation is only defined for the natural numbers and 0, that is for the whole numbers, and it is not defined for the negative numbers or fractions. So let's have some numericals based upon the factorial notations. The first numerical is evaluate 20 factorial by 18 factorial. The second one is 10 factorial by 6 factorial, 4 factorial. And the third one is 8 factorial minus 6 factorial divided by 3 factorial. We shall do these numericals one by one. Let's first evaluate 20 factorial divided by 18 factorial. Okay. You know, as 20 factorial is a product of first 20 numbers and 18 factorial is a product of first 18 numbers. So to calculate these factorials independently will take a lot of calculations. Okay. So to simplify this problem, what we do? We shall reduce the bigger factor to the smaller factor with the help of this formula. That n factorial can be explained as n, then 1 less, then 1 less, and we can stop wherever we require. So take this 20 factorial as, okay, expand 20 into 19 into 18. We are reducing the factor one by one. 20, then 20 minus 1, 19, then 19 minus 1, 18. And since the term in the denominator is 18 factorial, So we can stop at 18 factorial divided by 18 factorial, get cancelled out, and the calculation is quite easy now. It is 308. Okay. So without doing lot of calculations, with the help of this formula, this deduction, we have make our sum quite easy. Let's take the second example. 10 factorial by 6 factorial, 4 factorial. Again, the biggest among the three are 10 factorial. So we can reduce this 10 factorial up to 6 factorial or up to 4 factorial. So our main target is to make the calculations easy. So reduce this 10 factorial to 6 factorial so that the bigger factor will get cancelled out. So 10 factorial will be 10, 9, 8, 7. Where we stop? We shall stop at 6 factorial. Okay. And in the denominator we have 6 factorial. 4 factorial can be calculated with the help of simple calculations. Okay. Then 6 factorial get cancelled out. This 4 2s are 8, 3 3s are 9, and the result is 210. Next, you can take this example. Again, 8 factorial minus 6 factorial divided by 3 factorial. The biggest among these is 8. So reduce 8 factorial first to 6 factorial so that 6 factorial can get common. 8 into 7 then into 6 factorial. This is 8 factorial minus 6 factorial divided by 3 factorial. Okay. Now see, in the denominator we can take the 6 factorial common. So in the numerator we have 8 7s are 56 minus 1 divided by 3 factorial. Again see, in the numerator we have 6 factorial that can be reduced to 3 factorial of the denominator. So we can write it as 6 into 5 into 4 into 3 factorial divided by 3 factorial multiplied by 55. Right? So what the result will be? It's 120 into 55. So this is 6600. These are some particle numerical problems based upon the factorial notation. Let's now do some generalized numerical problems based upon the factorial notations. So let's have another numerical problem. Let's evaluate n plus 3 factorial divided by n factorial. Here n is not given to you, right? But you know, n is a natural number and we know that n plus 3 is bigger than n. So we can always reduce the bigger factor to the lowest. So reduce this n plus 3, decreasing the factor one by one. Okay, n plus 3, then n plus 3 minus 1 is n plus 2, then n plus 2 minus 1 is n plus 1, then n. But now, as the term in the denominator is n factorial, so we can stop at n factorial divided by n factorial. So the answer will be n plus 3, n plus 2, n plus 1. You can multiply these factors to get a polynomial in n. Right. Next, let's take some more problems. Find n if n plus 1 factorial is 12 into n minus 1 factorial. Okay. This type of problems come in the examination so that you have to find that natural number. One condition is given to you. So how do we do? We know that again n is a natural number and clearly n plus 1 is bigger than n minus 1. So what we do? We reduce the bigger factor to the smaller. So n plus 1 factorial. Let's reduce the factor one by one. It's n plus 1, then n, then n minus 1. So we should stop at n minus 1 factorial because on the right hand side we have n minus 1 factorial. So this is n minus 1 factorial 12 into n minus 1 factorial. Now n minus 1 factorial get cancelled out. So it will be n square plus n. In the right hand side we have only 12. So minus 12 is equal to 0. Now this is the quadratic in n. We can solve it easily by taking the factors. N square plus 4n minus 3n minus 12 is 0. The middle factor n. Okay. We have written this n as 4n minus n because 4 3s are 12 and 4 minus 3 is 1. So this is n into n plus 4 minus 3 into n plus 4. This is n plus 4, n minus 3, 0. So n can be minus 4 or 3. But you know, the factorial is not defined for the negative natural numbers, negative integers. So the value of n is 3. Let's take one more example of the same type. Find n if 2n plus 1 factorial, n minus 1 factorial, n plus 2 factorial, 2n minus 1 factorial is 3 by 5. So to solve this type of numerical problem, see it carefully that in the numerator we have two types of factor, in the denominator we also have two types of factors. Each factor in the numerator, the one factor is having 2n, another factor is having n. Similarly in the denominator, one factor is having n and another factor is having 2n. So we compare the factors containing 2n independently and factors containing n independently. So it is clear that from these two factors, 2n plus 1 is bigger than 2n minus 1 and n plus 2 is bigger than n minus 1, right? So what do? We reduce the bigger factors to the smaller one. So first reduce this 2n plus 1 factorial as 2n plus 1. Then 1 less than 2n plus 1 is 2n. Then 2n minus 1. So we can stop at 2n minus 1 because in the denominator we have the term containing 2n minus 1 factorial. So we stop at this. Again, as n minus 1 is less than n plus 2, so keep it as it is and reduce n plus 2 to n minus 1. n plus 2, then 1 less than n plus 2 is n plus 1, then n minus 1 factorial. Okay, and keep this term as it is so that it can get cancelled out with the term in the numerator. Right? Cancel this with this. And the right hand side is 3 by 5. Now see, this n also get cancelled out. Now what remains? In the left hand side we have 2 into 2n plus 1 in the numerator and n plus 1 into n plus 2 in the denominator. So we cross multiply these terms. So what we have? 10 into 2n plus 1 is 3 into n plus 2 into n plus 1. Okay? Multiply this. 20n plus 10 is 3 into n square plus 2n plus n plus 2 means 3 into n square plus 3n plus 2. This is 3n square plus 9n plus 6. And in the left hand side we have 20n plus 10. So take these terms to the right hand side, minus 20n minus 10, and this is equal to 0. It implies 3n square plus 9n plus 6 minus 20n minus 10 is equal to 0. Now this is the quadratic in n. 3n square minus this 20 minus 9, 11n, and minus 4 is 0. So 3 4s are 12. Okay. So do this as 3n square minus 12n plus n minus 4 is 0. Okay. So 3n taken as common into n minus 4 plus 1 into n minus 4 is 0. Now the two factors are 3n plus 1 into n minus 4 is 0. So n may be minus 1 by 3, n may be 4. But we know that the factorial notations are not for the negatives and fractions. So we discard this value and we get n is equal to 4. Okay. So you can solve many more problems of this type. Right? Next, we define a very basic principle in case of permutations and combinations, and that is fundamental principle of counting. That is commonly known as FPC. Fundamental principle of counting. Right? FPC. FPC. Or this is also known as principle of association of events. Principle of association of events. And it states that if an operation A can be done in m ways, following another operation B that occurs in n ways. Okay, or you can see two independent events A and B. The first occur in m ways, and after which the event B can occur in n ways. Then both the events in succession can occur in m into n ways. In total number of ways in which both A and B can occur in succession is m into n. And this principle can be generalized. Okay. It can be more clear with the help of, let's take one example. Say, suppose in a class, there are 25 boys and 15 girls, right? Okay, in a class there are 25 boys and 15 girls, and a teacher want to select one boy and one girl to represent the class in a function. In how many ways he can do this selection? Okay. So, what the teacher have to do? He can select the boy first and then the girl. He can select the girl first and then the boy. So, both the events are equally likely. You can select the girl first or the boy, but the main thing is that he have to select one boy out of these 25 boys. After then, he have to select one girl out of these many girls. So, the number of ways to select one boy is 25. Okay, and the number of ways to select one girl is 15. Okay, this is event A that can occur in 25 ways, after which this is an event B which can occur in 15 ways. So both the events, actually you have to select both boy and girl. So the total number of ways for selecting one boy and one girl are 25 into 15, and that is 75, 30, 375 years. Okay. So you can take one more example. In a railway compartment, six seats are vacant on a bench. Okay. In how many ways three passengers can have the seat or can occupy the seat? Okay. Now see what we have. There are 6 seats and there are 3 passengers. Suppose these are the 6 seats. Okay, and these 3 are the passengers. Okay, the passenger will be seated on these 6 seats one by one. So how many choices the first passenger can have? See, the first passenger have 6 choices. He can sit at any of the 6 seats. So the number of ways in which first passenger can have the seat is 6, because he may sit on any of the bench 1, 2, 3, 4, 5, 6. Once he is seated, suppose he sit on this bench, then the remaining benches are 5. So the second passenger have only 5 choices among the 6. So the number of ways for the second passenger, number of ways in which second passenger have the seat is 5. Now suppose he sit on this bench, then the third passenger is having only 4 options with him. So the number of ways in which third passenger can have the seat is 4. Okay, so this is event A that occur in 6 ways, event B after which 5 ways, and after which event C that have 4 ways. So by fundamental principle of counting, the total number of ways that 3 persons can have the seat is 6 into 5 into 4, and this is 6 5s are 30, 4 3s are 12, 120. Let's take one more example. How many numbers are there? How many numbers are there between 100 and 1000, so that you have 2 options. Number 1, 2 parts. Every digit is either 2 or 9. Okay. Say another, we want to calculate every digit is distinct. Let's calculate this one first. What we have to find? We have to find the number of numbers between 100 and thousands. Okay, you know, between 100 and 1000. See, mathematically, between 100 and 1000, every number is of 3 digits. Units place, tens place and 100 place. 3-digit number means it's ones place, tens place, 100 place. So, to do the first part of this question, we have every digit is 2 or 9. Okay, so digits can be repeated 2, 2, 2, 9, 9, 9. Okay, but every digit can be 2 or 9. So, every digit we have 2 options. For 100 place we have 2 options. For tens place we have 2 options. For ones place we have 2 options. So, number of ways for filling the 100 place. Hundreds place is 2 because it is either 2 or 9. Similarly, number of ways for filling 10th place, tens place, hundreds place, tens place is again 2. And number of ways for filling ones place again 2. Or unit place, you can also see it unit place. So the total number of ways, or you can say the total number of digits, not numbers, is 2 into 2 into 2, that is 8. So the number that have only 2 or 9 are only 8 between 100 and 1000. Now we will do the next part of this question. Every digit is distinct. Okay, so first keep in mind that between 100 and 1000 only 3-digit numbers are there, and also in those numbers 0 cannot occupy the 100 place, otherwise it will be a 2-digit number, right? So there is a restriction from total number of digits are 0, 1, 2 up to 9. We have 10 digits, but there is a restriction at the 100 place that 0 cannot come at 100 place. So we shall start with 100 place. So number of ways of filling, in this case, the number of ways for filling the 100 place exclude 0. So number of ways, how many ways 100 place can fill? 1, 2, 3 up to 9. So it is 9. Now the digit which came at 100 place cannot be repeated at tens place, cannot be repeated at ones place, because every digit is distinct. Now whatever the digit come at 100 place, leave that digit. Again the remaining digit can include 0. Now the remaining digits are again 9. So the number of ways for filling the tens place is again 9, because in this case we have excluded 0. So the digits are 9, and in this case exclude those which come at 100 place, and the remaining digits will include 0. So it is again 9. Now the 2 digits have occupied the place, 100 place, 10 place. Out of these 10 digits, one came here, another came here. Now the number of ways for filling the unit place or ones place is now 2 digits will go, it is 8. So the total number of ways will be 9 into 9 into 8. So it's 81 into 8. This is 8, 6, 4, 648 ways. So students, you can do many more problems related to these, right? Now we do the problems. First we can check, to come to the topic permutations and combination. We first explain what is the difference between group and arrangement. Difference between groups and arrangements. Okay. Now what is the difference between groups and arrangement? Group means select certain things out of given things. And arrangement means that arrange them. Let's take example. Suppose we have 3 alphabets A, B and C. And we want to make a group of 2 among these 3. From these 3 alphabets, we want to make or we want to select 2 alphabets. So A, we can select A and B. We can select B and C. We can select A and C. Okay. No matter we are writing first B and then A or first A then B, because group means both A and B are there. No matters whether A is written on the first place or B is written on the first place, right? So out of these, if we want to make group of 2, then we have 3 choices, either A or B, B and C, A and C. Okay, but if we want to arrange, if we want to make arrangement of 2, then arrangement means the position also matters. That means the arrangements A, B, B, A, both are different. In group, they are same. But in case of arrangements, they are different. So we have how many arrangements? C, A, there are 6 arrangements. So that is basically the difference between group and arrangement. So now we come to the definition of permutations. Permutations means number of different arrangements that can be made out of given things by taking some or all of them are known as permutations. Permutations. Okay. If you want to arrange n things by taking r at a time, if you want to arrange n things by taking r at a time. For example, this. We want to arrange these 3 alphabets by taking 2 at a time. Then the number of permutations is denoted by N, P, R or P, N, R. That means the permutations of n things taking r at a time. Next, the definition of combinations. Combinations mean making groups. So, what is the definition of combination? Combination is same number of different groups that can be made out of given things by taking some or all of them at a time. Is called number of combinations, and the number of combinations of n things. Combinations of n things taking r at a time. Taking r at a time. That is, suppose if you want to select or make group of 2 alphabets out of 3, it is denoted by N, C, R or C, N, R. So, that means now the concept should be clear in your mind that the permutations means to arrange the things and combination means to select the thing, or to make the groups of the things, or to combine the things. I think that's enough for this lecture. The numerical problems related to permutations and combinations will be done in my next lecture. Till then, thank you. Bye.